We got done with this. Any other question from this part? Hmm?
No.
No. Vanita? Vanita? Vanita?
What do you say?
Give me one use of the acid. Hmm? What do you use acids for? Hmm? What do you use acids for?
They are used in the laboratory.
To do what?
Experiment.
Yeah?
Experiment.
To what?
Experiment.
That is their use.
Like,
Acids have many uses. They are used in car batteries. Also, some are used in ripening of fruits. If you want to make soap, some are used there. So they are as many as this. So this one I will not do it, you will read. Okay? Is it fine?
this is an alkaline.
Good. So now let's differentiate. Someone give me the difference between the base and the alkali. We looked at them earlier on. What's the difference? Base and the alkali. And the alkali. What's the difference between the two? Hmm? There's no one. What is the base? Hmm? Hmm?
Which one dissolves?
The base?
Base is a substance.
Mm-hmm.
Which one dissolves in an acid produces salt and water?
Is it what? Is it what?
It is a base is a substance which reacts with an acid to form salt and water only.
Reacts with the acid to form the salt and the water
Salt and
only.
water.
That's okay. Then the alkali?
It is a base that dissolves in water to produce hydroxide ions as the only negatively charged ion.
That is the difference between the alkali and an acid. Acid produces which ions? Hydrogen ions as the only positively charged ions. The alkali produces the hydroxide ion. This is OH, all of them -1. It only produces the hydroxide ion as the only negatively charged ion. Negatively charged ion. The reason as why we use a base and an acid in preparation of certain salts. Like which salts? Like which salts? Salts of sodium and sodium and Maya. Sodium and what? Sodium and potassium. If you use the alkali and an acid, which method is this? Which method is that? The method is called The method is called what? Lynette.
Neutralization.
Yeah? The method is called what? You are neutralizing the acid using a base. The only way you can neutralize acid, you can use a base, or you dilute furthermore with water. Huh? So that is the only way you can get the difference. Now, when it comes to this, there are only two things here. They're saying a strong alkali is the one that ionizes completely in aqueous solution. That one we have known to form what? So here we have the difference. A base is a substance which reacts with an acid to form salt and water only. The definition is okay. Examples of bases are mainly oxides of metals, copper oxide, zinc oxide, calcium oxide, magnesium oxide, and then hydroxides of metals also. Like which hydroxide? Sodium hydroxide, potassium hydroxide, and as many as they are. So if a base dissolves in water, it gives us the alkali. The only negative ion it produces is the OH. So an alkali is a base that dissolves in water to produce hydroxide ion as the only negatively charged ion. So according to that, what's the difference between a strong and a weak alkali? According to what we have defined the alkali. What is a strong and a weak alkali?
A strong, so let me try.
Yes.
The strong alkali is the one that dissolves in water.
Use the right word. Doesn't dissolve, but
It ionizes.
So let me try.
it ionizes or dissociates in water. Someone.
Dissociates.
Then the weak one.
It's an acid that does not completely ionize in water.
It is not an acid. It is alkali.
An alkali that does not completely ionize in water.
So an example is this: ammonium hydroxide. It gives you this and that. Okay. So when they talk of a weak alkali, you know that ammonium hydroxide is an example. If they we talk of strong alkalis, we have sodium and what? Potassium hydroxide.
Potassium.
When they go into water, they give us sodium ions and hydroxide what? Ions.
True.
So that is the only difference they have there. So they undergo what we call neutralization reaction. If you want to form a salt with those, you undergo neutralization reaction. This is a reaction between an acid and a base to produce what and what? Salt and water only. So if you know how those things react, then indicators, these are just minor things. Is an indicator, is acid-base indicator, is a substance that shows the difference, shows different colors in the acidic and alkaline solution. Now, if you go through this, these are some of the ways you can make a simple one. You can get any colored flour at home, and you get ethanol, crush them together, and you get a lemon and pass through it. You will know what the indicator does. Okay, so you get a flour, crush it in a smaller mortar or any other thing at home you can use. Then use anything like ethanol if you get one. Those who make it at home, get just some little and add it there. Shake and filter off. Get an orange or some other thing that has acid in it and squeeze and get drops of some few drops of that orange.
Question.
Yes.
What if you don't have ethanol?
Because it is the only easiest thing you can get at home. Which other thing can you use? Methanol is there.
I don't have any.
Oh, what are you have? You know what I
Yeah.
yeah?
It
At least that one you can. Mm.
Teacher,
Mm.
what about like what if instead of ethanol you use sanitizer?
Yeah, so sanitizer as part of it.
Okay.
So sanitizers, which percentage? The percentage varies, isn't it? But most commonly used is about
99.9.
95, 99 as you go on. Is that clear? So get that and try to use. So I want to look at this, the pH. This is the power of hydrogen. So if you look at the pH scale, it measures the strength of an acid or a base or alkali. So the pH scale runs from 0 to 14. From 0 to 3, those are strong acids, if you look at that. Then from 5, 4, 5, 6, those are weak. Then neutral is 7. Which compound gives us a neutral pH? 7. The most common is what? Yes?
Ammonia.
When you talk of those things, those are alkalis. Now you are going to add sides of the alkali. When you talk of hydrogen ions, you are talking about acids. When you talk of hydroxide ions, you are going to the alkali side, isn't it? Okay? What is the
Yes.
pH of water?
P-
It is?
7.
So that is the only substance that at least we know it is neutral. What about the waragi, you know? Where does it fall?
Alkaline.
Waragi is alkaline.
Strong alkali.
Eh?
Strong alkali.
Waragi.
Strong acid. Strong.
Strong acid.
Let's go back and see where do these acids fall? This one here. These ones. Sulfuric acid.
0 to
Where
3.
does it fall?
0 to 3.
0 to 3. Hydrochloric.
0 to 3.
Then
3.
then this one. Carbonic acid.
4 to 6.
Then ethanoic.
4 to 6.
Good. So that is one. Now let's look at this. What about these ones? This base. Sodium hydroxide.
11 to 14.
Then
They are
potassium.
strong.
They are strong bases, isn't it? Strong alkalis. So strong alkalis start from where to where?
11 to 14.
Yes? Let's try to speed up because we have the other left bit that we are going to calculate. So some of
11
these,
to 14.
that's where they fall. Now, if you look at weak ones, weak base like ammonium hydroxide, where does it fall?
8 to 10.
8 to 10, that's where they fall. Weak ones are there, strong ones are there. Okay? So that's what happens. Finally, we fall on this, then we'll go and calculate. Somebody was asking about, let me look at this, the difference between soluble and insoluble salts. The difference between soluble and insoluble salts. What is the difference? Someone is shouting on the ground. What is the difference between soluble and insoluble salts?
Soluble salts are prepared using neutralization, while insoluble salts are prepared using direct.
Using what? Using? Hmm? Lynette? Lynette? What were you saying? That what?
I said that soluble salts are prepared using neutralization,
Utilization.
while insoluble salts
Mm.
are prepared using double decomposition.
Double decomposition. Now, in relation to a solvent and a solute, if something, let's take an example, the most common solvent used is water, isn't it? Yes? The
Yes.
most common solvent is water. If something is soluble in water, if something is soluble in water, that salt is considered what? If it dissolves in water, that salt is considered soluble. If it doesn't dissolve in water, does not dissolve, that salt is called insoluble. Now, who was this one? So if the salt does not dissolve in water, that salt is considered insoluble. So the difference is soluble salts dissolve in water, insoluble don't dissolve in water. Or any other organic compound, if it doesn't dissolve, that salt is considered insoluble. If it dissolves, then it's called soluble. So apart from water, you can use ethanol as your organic compound, ethanol. So if you dissolve something, is dissolved, it is soluble in ethanol, or it dissolves in ethanol, then it has given us a soluble solution. If it doesn't, then it is insoluble. Is it clear? Yes?
Yes.
Yes.
Okay. Now here they are saying all salts of sodium, all salts of sodium, potassium, and the ammonium are soluble in water. Now they are taking an example of solubility in water. Our water is a solvent. All salts of these, sodium, potassium, and ammonium, all of them dissolve in water. What they mean salts of this is can be either their carbonates, it can be their sulfates, it can be their nitrates, or their chlorides. So sodium carbonate, potassium sulfate, ammonium chloride, all these salts are considered soluble in water. So whichever you get, it dissolves in water. Someone had a question?
No.
Okay. So all these salts are considered soluble. Now, if you look at carbonates in particular, they say it is only these that are soluble among the carbonates. 1, 2, 3 are the ones that are soluble. The rest do not dissolve. The rest do not dissolve. Someone give me an example of what they are meaning, the rest. Example of the rest of the carbonates that don't dissolve in water. 1. Shelly.
Yes, teacher.
An example of an insoluble carbonate? Because they are saying the rest, we don't know an example. Yes?
Barium.
Barium what? Carbonate, isn't it?
Yes.
Barium carbonate. Two. They were talking about carbonates. Elise.
Zinc carbonate.
Zinc carbonate. Thank you. Letitia. Apart from sodium, potassium, and ammonium carbonates, give me an example of a carbonate that doesn't dissolve in water apart from these two, barium and zinc. Cynthia.
Is aluminum carbonate there?
Aluminum carbonate doesn't exist.
Oh,
It is the only salt that doesn't form carbonates. Frida. So there are many others. As long as you look at your periodic table or reactivity series, there are many. Apart from this, we have copper carbonate, as many as that. So apart from this that dissolve among the carbonates, the rest do not dissolve. When you look at sulfates, apart from lead, barium,
boron, calcium,
and calcium, that is sparingly soluble. The rest dissolve in water. An example of the rest of the sulfates that dissolve in water, these ones do not dissolve. The rest, one, Vanita. These ones do not dissolve. An example of a sulfate that's soluble in water. Sodium sulfate, yes. Sodium sulfate. Another one, Patricia.
zinc sulfate.
Zinc sulfate, yes. So there are as many as that. When you talk of chlorides, apart from lead chloride and mercury chloride and the silver chloride, the rest dissolve. These ones do not dissolve. Don't dissolve in water. The rest dissolve. An example of the rest of the chlorides that dissolve in water, apart from the one of sodium, potassium, and ammonia, copper, chloride, zinc, chloride. List.
Sodium chloride.
Sodium chloride, we have talked about it. So apart from this, that don't dissolve, the rest dissolve. So these are examples of them. What about nitrates? That one is a known case. All of them dissolve. All nitrates dissolve in water. So I have answered salts, soluble and insoluble ones. Who hasn't got or who hasn't understood that? Frida. Treasure. So if that is done, allow me drop to these salts here. But this one, we looked at them. Normal salts produced when all the ionizable hydrogen of the acid is replaced by metallic or ammonium ion. That one we know. Acid salts formed when a part. So the potassium hydrogen carbonate is an acidic salt. part of the hydrogen, only part of the hydrogen of the acid has been replaced by the metallic ion. Then here, all the ionizable hydrogen of the acid has been replaced. That is a normal salt. An example is this: ammonium nitrate, sodium chloride. All the acid on the chloride, hydrochloric acid, has been replaced by sodium. Here, only part of the acid, like sulfuric acid, they have replaced only part of it. Part of this has been replaced by the metal. So you are getting sodium hydrogen carbonate. So this one is an example of the acid salt. So that is part of that. So we are running straight to this part that had problems in it. So this was the concern, isn't it? Okay, I've understood that. So where are these people? Letitia,
Yes, teacher.
pen and paper is there. The pen and the paper.
Yes.
Okay. So get your pen and paper. We do a little of this. We have about how many minutes left? About 10 minutes left to finish up this. Letitia, what does the word solubility mean? Hmm? Letitia?
I'm here.
Yes. What does the word solubility mean?
Solvent.
Solubility
Mm-hmm.
means, I don't have the right definition, but I can explain it.
Use yours.
Okay.
Mm.
Solubility means the amount
Mm-hmm.
of a solute that can
Amount.
dissolve in 100 grams of a solvent.
Amount of a solute in grams. Okay?
Yes.
That
Can dissolve.
that can dissolve.
That can be dissolved. That can be dissolved.
That can be dissolved.
In 100 grams of a
100 grams
solvent.
of a solvent.
Brackets water.
So if you took that at a particular temperature, isn't it? At a particular
Temperature.
That is it. So here we are looking at solubility amount of a solute in grams required to saturate 100 grams of a solvent at a particular temperature. As long as you get the amount of a solute in grams that can saturate 100 grams of a solvent at a particular temperature, you are determining solubility of that substance. We looked at an example of sugar and water. We say the sugar is our solute, then the solvent is water. So if the amount in grams of sugar that is required to saturate 100 grams of a solvent at a particular temperature, then that is solubility of sugar at that particular temperature. So here they are saying, we looked at these ones. We shall not go back to this description here. Now there was a question that was posted this side that looks like that part we did. The question is here. They are saying, determine solubility of water or substance. Determine solubility in water of substance S at room temperature from the following data. This is the mass of the evaporating basin. They have given us mass of the basin as 25 grams. Mass of the evaporating basin plus the solution. This mass of the basin plus the saturated solution. Saturated solution, which is 55. Now, after evaporating, this is mass of the evaporating dish, evaporating basin plus the solid S. Now it is 30 grams. We have this data here from the question. They want us to calculate solubility. If you look at this example provided up here, that take about 50 of distilled water in the beaker. Now, this is determining solubility of a salt. An example, sodium chloride. They got 50 cubic centimeters of water in the beaker. They added salt crystals to water a little by little to make sure that it's saturated. It cannot take in any more salt. Then they weighed. After this, they did what? They filtered off the excess salt that wasn't dissolved. Then they weighed the evaporating dish and the clear salt solution after filtering off the other undissolved one. This is what they have. So here we have the mass of the benzene. Like an example here, the mass of the beaker. Now here, this is the mass of the beaker. Let's take this as our beaker. It was a benzene. It was 25 grams. Now here they are saying weigh evaporating dish plus the clear salt solution. This is now the benzene plus the saturated solution that was there gave us 55 grams. Now these two, here we have about three things. We have the mass of the benzene here in 55. In the saturated solution, we have two things. We have sugar or maybe the salt and what? The water. So we have benzene, we have the salt, we have the water in 55 what? Grams. Here they are saying weigh the evaporating dish, this one also. The evaporating dish is there and evaporate the solution to dryness. So now here we have the mass of the evaporating basin and the solid to give us 35. So if you have here, here there are two things. We have the mass of the evaporating basin and the solid S. So if you get the mass of the evaporating basin, you subtract it from the mass of the solid, you will be getting this is the total mass of both of them. If you subtract from this total mass the mass of the benzene, you'll be getting the mass of the solid. Mass of the solid. That was there in the saturated solution. Saturated solution. Now the procedure is this. Mass of the empty dish is A. We have it, 25. Mass of the dish plus the saturated solution is B here. We are having both of them as 55. Mass of the dish plus the dry salt is C. So all this one gives us C. So C is 30. So now the mass of the saturated solution, mass of the saturated solution, mass of the saturated solution is going to be 55 grams minus 25 grams, because we have both the mass of the benzene, which is this, and then we want the mass of the saturated solution. It's going to be this minus 25. This one here minus 25. If you subtract the two, what do you get? 55 minus 25, what do you get?
30.
30 grams. So the 30 grams are for the saturated solution. But in our calculations, we need the mass of the solute in grams, and then we need also the mass of the solvent in grams. Now we have the mass of the saturated solution. The saturated solution has both. It has both the solute and the what? And the solvent. Now, how do you get the mass of the solute? Now here you have the mass of the dish and then the mass of the dish and the mass of the solid. If you have the mass of the solid, and the dish, you have got the mass of the evaporating basin. The mass of the evaporating basin was what? Was it? What was the mass of the basin? Because we are looking for the mass of the solute.
Mm.
Mhm.
You're asking for the mass of the basin. It's in my network.
Okay. What have you said? Somebody was talking. We don't have the mass of the solute, we don't have the mass of the solvent, but we have the mass of the basin and the solid. So if I subtract the mass, for me to get the mass of the solute, our solid S, I will get this one, mass of the basin, and this, because I have the mass of the basin as 25, isn't it? Yes?
Yes.
So it's
Yes,
going
sir.
to be, to get the mass of the solid, I will say mass of the basin, okay, mass of both the evaporating dish, evaporating basin, plus the mass of the solid, minus the mass of the basin that was up, minus mass of the basin. I think we shall